So next we have the Chinese remainder theorem, that is, let m1, m2 up to so on mr be relatively prime numbers such that GCD of mi and mj is equals to 1 for all I not equals to j. That means there are some number and these all numbers are relatively prime. That means if I find the GCD of m1 and m2, so that result is 1, and if I take the GCD of m2 and m3, so that result is 1. So let m1, m2, m3 up to so on mr be relatively prime numbers, or I can say co-prime, such that GCD of mi mj equals to 1 for all I not equals to j. Then the linear congruences, I can say x, that is congruent to ai mod m1, x is congruent to a2 mod m2, and x is congruent to ar mod mr, has a simultaneously simultaneously solution which is unique in modulo m1, m2 and mr. So this is basically you can say the definition of the the statement of the Chinese remainder theorem. So basically we use it to solve the system of linear congruences. So by solving these equations I get a simultaneously solution which is unique. So we have to prove this result or this theorem. So for this I am taking let m, that is the product of m1, m2, m3 up to so on mr. Then for some k, that is from 1 to r, I can say that mk, that is equals to m divides mk, small mk. And here m, that is the product of m1, m2, m3 up to so on mr. So putting this value of m here, so mk cancel out with mk. So the remaining terms are m1, m2, m3 up to so on mk minus 1 and mk plus 1 up to so on mk. So here is the value of mk, that is m1, m2 up to so on mk minus 1, mk plus 1 up to so on mr. So if this is the general form, and if I can write it in the form of the m1, so I can write it as m1, that is equals to capital M over m1. So capital M, the value of capital M is basically m1, m2, m3 up to so on mr, and if m is divided by m1, so m cancel out, I have only this result, that is m2, m3 up to so on mr. So similarly like that I have the value of the m2. So from this I can say that, or in the as we all know that m1 in the, you can say in the statement that m1, m2 and m3 up to so on m are relatively prime. That means the GCD of these numbers are 1. So if these numbers are relatively prime, then capital M1 and small m1 are also, you can say, prime, relatively prime, because their GCD is 1. So m1, capital M1 and m1, that is equals to GCD of capital M1 and small m1 is 1. So that means GCD of capital M2, small m2 is also 1 up to so on. As you can say, the GCD of capital MR and MR is also 1. So if the GCD of these all terms are 1, then there exist an integers. I can say that C1, C2 up to so on CR, such that I can write it as in the form of this term, that M1 C1 is congruent to 1 in modulo M1, small m1. Now further is, I can write it as M2 C2 is congruent to 1 in modulo small m2. Like that up to so on, I can write the journal form like this. Now in the next step, what we have to do is we have to construct an integer. So let us construct an integer in the form of the v, that is equals to m1 c1 a1 plus m2 c2 a2 plus up to so on mr cr ar. That means v is congruent to this one, and also v is congruent to this one in modulo, I can say, small m2, and v is congruent to mr cr ar in modulo, I can say that mr. So now I can say that let S denotes the set of all common solution of the given congruence. I am now finding the solution of these equations. So S is basically the, I can say, the set of the common solution of the given congruences, or I can say that V is the element that is like which belongs to S. So for this, now we have to check the uniqueness here. So we have to show that S is V of M is basically the residue class M of V. So for this, we have to suppose that for some, you can say alpha belongs to S, or you can say X belongs to X. I can write it as alpha is congruent to A1 in modulo M1, and alpha is congruent to A2 in modulo M2 up to so on. Alpha is congruent to AR in modulo MR. So that means I can say that M1, M2, M3 up to so on MR divides, you can say that V minus, V is basically the number which belongs to some S, V minus alpha. So this implies M1, M2, the product of this one divides V minus alpha, and this implies that, and this whole term is basically the capital M. So capital M divides V minus alpha. So V is congruent to alpha in mod, I can say that, capital M. So M here, as we discussed earlier, is basically the product of M1, M2, M3 up to so on MR. So V is congruent to alpha. So this is that numbers. Thus the given congruence has a unique solution in modulo M1, M2 up to so on MR. So from this method, I found the result of the system of linear equation like this. So I found a unique solution of this system of linear equation. Now in the next slide, in the next video, I'm going to take some example and solve this linear system of linear equation by using the Chinese remainder theorem. I am using this method and solve the example.